This video will cover the topic of writing one-step equations by using graphs and tables. Be sure the date and topic are at the top of your page. The essential question asks us, how do we convert a table into an algebraic equation? And this will also work with graphs, but most of the time you'll turn your graph into a table prior to then creating an equation. When we think about algebraic equations, what we're thinking about are expressions of a algebraic relationship using variables and calculations. And of course, these variables that we're going to be using will be letters that make sense within the context of the story or of what we're trying to express. So for example, if we were doing an equation that had something to do with dogs, maybe we would use the letter D, right? Or if we were doing something with miles, maybe we would use the letter M, right? But we wanted to have some sort of context. We want it to make sense within the context of the story. An algebraic equation can also be thought of as a rule, as the rule will tell us how we get one value by using the other. And that rule will also help us to calculate missing information when given just pieces of data. Let's start with this example where it says that every student who went on the field trip needed to pay $6 to be able to participate in the roller skating. With that information, we can fill in a table, and it won't cover every student who went, but we can fill in some information that shows us the price that it would be for a specific number of students who have attended. So of course, if no students attend, right, we wouldn't have to pay any money. If one student comes, that would be $6. 2 students, we would need to bring $12. 3 would be $18, and of course 4 would be $24. To turn this information into an equation, we're going to need some variables. So we can probably use S for students. Just be careful that our S's don't look like the number 5, because that can happen sometimes. And also, let's go ahead and use P for the total price. We're going to need an equation that shows the connection between these two, right? So even if I just say this out loud, I can turn that into my equation. The price that we pay is equal to the number of students times 6. And I know it's times 6 because it's $6 per student. I also know that when I'm adding one student at a time, I'm adding $6, and that's where it shows up in my table. So for every one extra student, I added $6. With my sentence written out here, I'm just going to take my same information and put it into algebraic form. So the P, of course, would be our price. Tells me to have my equal sign. $6 right here times the number of students. And I'm not going to put a little X right here because that would be confusing. So I'm just going to do 6 times the number of students. And that's it. That's our whole equation, right? This 6 has a name, right? We've talked about it a couple times before. The number in front of a variable is called a coefficient. And you might notice that that coefficient is the same number as our table as we increase it one student at a time, right? This 6 shows up here in our table, and it's the same number that is our coefficient. With our equation now, we can actually use it to find out information that wasn't in the table. So for example, I might say something like, how much would it cost if 120 students went on the field trip? To do that, right, I can use my equation and say, well, the price, which is what I'm looking for, is still unknown, but I can do it by finding 6 times 120 students. And then I just need to solve that to figure out what the price would be. And if I went through that calculation, I would see that the price would be $720, right? I don't have to make the table go all the way up to 120. I don't have to draw a graph all the way up to 120. But with my equation, I can just plug in what I'm looking for and what I know and find the missing variable, in this case, the price. We can also use our equation to work backwards. So in this case, it says how many students paid if I have $108. So in this instance, I know how much was paid. I know that there was $108 paid. I know that it's $6 for every student, but I don't know how many students, right? So this will require me to do some backtracking. Since 6 was being multiplied by the number of students to get 108, I'm going to backtrack by dividing 108 by 6. And you'll see this set up more next year, and I'm just kind of showing it to you, but our backtracking system will always work as well. But you would do 108 divided by 6 to figure out how many students had paid. And if we went through that calculation, we would see that there would be 18 students. So here we've solved for S, we've solved for the number of students by backtracking using our equation that we wrote from our original table. So we just have one last example of a table, and we want to try to make an equation that matches this table. So the first thing you want to do is figure out what your variables will be. I see that we're comparing riders and bus fare, so perhaps R would be a good place for us to start with riders, and maybe F would be the fare that people are paying. All right. And so by looking at the information from the table, we should be able to come up with an equation that matches. So take a moment to write an equation using variables that will show how much the bus fare would be for any number of riders. Does your equation show $2.50 times R equals F for fare? If so, that matches mine, and that'll work, right? That's a great way to show the relationship between the riders and the bus fare. And we would be able to then go on and use this equation to figure out how much it would cost for 10 riders or 30 riders or 72 riders. And we can also work backwards if we know how much we've paid to figure out how many riders there were. So remember, the essential question of this video was just to introduce how we could convert a table, information from a table, into an equation using variables. We'll see in our next video how we might do this if we have 2 steps in our equation. Right? These are just one-step equations, but we'll be adding 2 steps and so on in the future.